Okay, so we'll discuss week 3 of the constrained and unconstrained optimization course. And in week 3, what was discussed was mainly what was discussed was the two-phase method. Two-phase method. I think I didn't share my screen. Yeah. So we discussed the two-phase method, which is used when you have artificial variables. Basically, you use this to do your simplex, and these artificial variables are used uh, to get the initial BFS. So we had seen in week 2 when we were using the big M method, we had used these artificial variables, and in the objective, we if the artificial variable is some x k, then we add in the objective we added plus m x k, where m is some large positive value. Okay, this was the big M method, and because here we have to make some choice of m, and we may not know that our choice of m is correct or not. So as an alternative to that is the two-phase method, where we don't really need to choose this value of m. Okay, so and uh, and we also looked at like what was discussed in week 3, I think, is uh, some cases of LPP where you have unbounded solutions, infeasible solutions, infinite solutions, and how to deal with degeneracy, the Charnes perturbation method, and a brief introduction to post optimal sensitivity analysis. Okay, so we'll solve some problems, and which are which include these methods. Okay, so let's look at the first question. Okay, we need to solve this using two-phase. Two-phase method. Okay, let me erase this part. Okay, so we need to get our initial BFS, and as you can see, here there are equality constraints, and our initial BFS with the uh, identity value as our B matrix. To get that, we will need to add the auxiliary, artificial variables. So we will do what we'll do is we'll have x1 plus 2x2 x1 plus 2x2 plus x3. We can keep this as it is. We may not need an artificial variable in the first constraint, but we can add one here. 0x3 plus x4 equal to 8. Okay, and now here is 0x4. So in the two phase method we have phase 1 and phase 2. In the phase 1 we change our objective function. So how do we change that? You write your z star max z star equal to 0 x1 plus 0 x2 plus 0 x3, plus we have an auxiliary variable. For that we give minus x4. Okay, minus 1 times x4, and we have the constraints subject to x1 plus 2. I'll just copy this. Okay, so basically I need to do my simplex for this problem. This is our phase 1, and if you look at this, uh, yeah, I also have the positivity constraints. So basically, would my to maximize my objective, whatever value of x1, x2, x3 I choose, they don't really matter. But my x4, which is my artificial variable, if I choose a positive value for it, I'll get some negative value here. But if I choose it as 0, my objective becomes 0, and that is the best that I can do, because otherwise I have to choose a negative value if I have to go get a objective value less than 0. And sorry, if I need to get an objective value more than 0, then I'll have to choose x as a negative value, but my positivity constraints prevent me from doing that. So yeah, what were we doing? Yeah, so yeah, I need to do the simplex on this. Basically, if I do the simplex, I'll iterate through my corner points, right? So let's do the simplex on this. So what is the simplex? You have your basic variable x, b as x3 and x4, and your b initial solution has 6 and 8. Okay, you joined right now, I think. Can you hear me?
Yes, yes, I can hear you.
Yeah, so I had just started the recording.
Okay, fine.
So basically what I'm doing is we are solving this using the two-phase method. So two-phase method, if you recall, in the week 1, it was an alternative kind of to the big M method. Sorry, in week 3 it was discussed this week. It is an alternative to the big M method, and you don't have to choose a M value basically when you are using this two-phase method. And in phase 1, what you do is you give an objective like 0 coefficient to your original variables, including those slack and surplus variables, but to the artificial variable that you added, you give a -1 coefficient. Okay, and then you do the simplex.
Yes, yes, yeah.
So I'm doing the simplex. I have my basic variable as x3, x4, and I start with start with this basic variable. So I'm writing the simplex tableau. So I have this. I have x1, x2, x3, x4. this will be 1 2 1 0 2 minus 1 0 1, and I'll have Cj, which is 0 0 0 minus 1, and Cv is minus. So I'll do the simplex. So I need to compute Zi minus Zj minus Cj, right? If I do this, what do I get? 6 minus 16. No, sorry, I'm doing the correct. I should multiply this and this. So it will be minus 2 2 0 minus 1, right? That's correct. And I need to compute b by x, right? So this is my negative, most negative one. If I do b by xj, I get 6 and 4. So this is my uh, pivot point. So x1, x4 will depart and x1 will enter. So if I do that, x3 and x1, x3 coefficient is 0, x1 is also 0. I need to make this 1, so this will be, I'll divide by 2, minus 1 by 2, 1 by 2, and I'll subtract this row from this row to get 0 there. So 6 minus 4 is 2, 1 minus 1, 0, 2 minus 2 plus half. 2 plus half is how much? 5 by 2, right? 1 plus 1 minus 0 is 1. 0 minus half is minus half. Okay. So I have Zj minus Cj. So I'll get, I guess, 0, 0, 0 and 1. Right. So all are greater than equal to 0, so we can stop here. And now I need to look at uh, what are there in my BFS. So I have x3 and x1, but my artificial variable is not there in the BFS. Right, x4 was my artificial variable, and that is not there. So we can drop it in our second phase. So now we start the second phase, phase two, and I uh, drop the artificial variable.
Uh, I have one doubt.
Yeah.
Uh, if artificial variables leave the basis in the
Mm-hmm.
phase 1,
Hmm.
in the subsequent iterations of the phase 1, we can omit x4 artificial variable or not, like in the simplex table.
Uh, I didn't get your in the subsequent iteration of what?
मैं कह रहा हूँ कि अगर आर्टिफिशियल वेरिएबल बेसिस में है
Huh?
और बेसिस को लीव करता है, उसके
Huh?
बाद बट फेज 1 की आइटरेशंस अभी ख़त्म नहीं हुई हैं, तो क्या हम फेज 1 में ही आर्टिफिशियल वेरिएबल का जो कॉलम है वो हटा सकते हैं?
Oh, like that.
यस।
I
फेज 2
think.
में तो हटाएंगे ही, क्या फेज 1 में ही कर सकते हैं?
Yeah, I think you can do that. Yeah,
ओके।
but that's how what we did in the beginning, right?
या, यस यस यस।
Yeah, you can do that. Yet I am not sure actually. Can we do that?
बिकॉज आई वाज आल्सो नॉट सर।
Maybe I'll check it. I'll let you know.
ओके ओके फाइन, नो प्रॉब्लम।
Yeah, I'm not sure actually. No, that's a good question. I didn't think about that because when you are using it in practice, you don't think about
यस यस।
it. Yeah. So okay, so let's continue this. Uh, so in phase two, what do? We retain our original objective, right? Which was z equal to, sorry, z equal to x1 plus 5x2 plus 3x3, right? And we don't need to add the artificial variables in the objective now, and we'll do our simplex with the above thing. So what do we do? So we'll copy this part. I don't need x4, right? And my this is b, x1, x2, x3. And c, j, which is 1 5 3. Okay, now I have to recompute this. So x3 coefficient is 3, x1 is 1. So this is 0, this is 15 minus 1, that is 14 by 2, 7, 7 minus 5 is 2, is 3 minus 3, that is 0. Okay, so we got that j minus c j greater than equal to 0 for all. So we have the optimal solution. That's correct. And x2 equal to 0. How can we verify whether this is correct? x3 equal to 2 and x1 equal to 4, right? Substitute this, I get 4 plus 6 equal to 10. Does this look okay? Let me try some value and just check. Let's say I put x3 equal to 0. And then I get x1 plus 2x2 equal to 6 and 2x1 minus x2 equal to 8. So I can do make this 4x1 minus 2x2 equal to 16, and if I add these two I get 5x1 equal to 22, right? So x1 equal to 22 by 5 and x2 equal to 8 2 into 22 by 5 minus 8, which is how much? And how much will this give me as my objective? So x1 is 22 by 22 by 5 plus x2 is 4. This is how much? 42 by 5, which is less than 10. So this seems okay. Okay. Any doubts in this? Yeah, then that what you asked about whether we can drop that artificial variable before in phase 1 itself, and that I need to check.
Yes, okay, no problem.
Okay. So let's do another question. If we need to solve this, we can do with whatever phase 1 method or anything. And we don't need artificial variables in this, I think. So we have can just do this plus x2 plus x4 equal to 4. So we have cj s2 4 0 0 x1 x2 x3 x4. Basic variables are x3 x4. cb is 0 0 1 2 1 0 and 1 1 0 1. And I need to do j minus cj. So again minus 2 minus 4 0 0. So then I do, okay, I wrote should written b value, which is 5 and 4. And basic variables x3 x4 and cb is 0. So if I do b by x1, I get, sorry, b by this is my entering variable. To get the departing variable, I get 5 by 2 and 4. So this is smaller. This is my pivot. Okay. So I'll have x3 will depart and x2 will enter, and here I have x4. So x2 coefficient is 4, x4 is 0. To make this as 1, I'll divide by 2. So I get 5 by 2, 1 by 2, 1 by 2, 0. And subtract this from the second row. So 4 minus 5 by 2 is 3 by 2. 1 minus half is half. 1 minus 1 is 0. 0 minus half is 1 minus half. And 1 minus 0 is 1. Zj minus Cj. This will be 2 minus 2, that is 0. 4 minus 4 is 0. 2 minus 0 is 2. And this is 0. Okay, so we got Zj minus Cj greater than 0. Now I'll look at that b by xj ratio. No, sorry, I don't need to do that. I don't need to do that. No, I wouldn't get that. Okay, so we got the positive values for Zj minus Cj. Now if you look at it carefully, we have a non-basic solution with 0 value. Okay, so what does that mean? If I have a non-basic solution with 0 value, any guess?
Infinite solutions.
Yeah, so that means we can bring this into the basic set, right? So one of the solution here is x2 equal to 5 by 2, x4 equal to 3 by 2, and x1 equals 0, x3 equals 0. But we can bring in the basic for a feasible solution into this. So let's replace x4 by this x1. So how do I do that? So this I am choosing. So I can divide by half, right? I will get 3, 1. This is x1 coefficient is 2. 0 minus 1 2, and I'll subtract this row from that row. So 5 by 2 minus 3 by 2 will be 1 is 0. 1 and half minus half will be half minus minus half, that is 1, and 0 minus 1 is minus 1. So again I can look at zj minus cj. So this is 2 minus 2 0, 4 minus 4 0, and this is 4 minus 2 2, and minus 4 plus 4 0. So it says we can again make x4 and so on. So this is infinite solution. We got one more solution, that is x2 equal to 1, x1 equal to 3, and x3 equal to 0, x4 equal to 0. So basically if you take any convex combination of these, and that will also be a solution. So that's why there are infinite solutions. Okay, let's look at a different question. So same kind of thing here. Can do x1 minus x2 plus x3 equal to 10, 2x1 plus x4 equals 40, x1 x2 greater than equal to 0. So if I make my simplex tableau, I have cj as 2 1 0 0. And x1 x2 x3 x4 b xb and c. Minus 1 1 0, 2 0 0 1. If I compute this, I get minus 2 minus 1 0 0. Look at b by xj, that is in this column I have 10 and 20. This is my pivot. So x3 is replaced by x1, x4, x1 coefficient is 2, still 0. So we already have this as 1. This one we will do 2 times row 1, like row 2 is row 2 minus 2 times row 1. So 40 minus 20 is 20, 0, 2 minus 2, 1. do zj minus cj. What do I get? 2 minus 2 is 0, minus 2, minus 1 and minus 3, 2, and this is 0. This is my entering variable. This I get as 8 minus 10 here and 10. So what does it mean if we have a negative value? We don't look at that one, right? Look at the positive value ratios. So this is my pivot. So I have x1 and x4 departs and x2 enters. So I'll divide by 2 this row. And I'll do row 1 as row 2 plus, sorry, row 1 by row 2 plus row 1 by 2. So row 1 by 2 we have already done here, so we will add this to it. 1, 1 minus 1 is 0, minus 1 plus 1 is 0, half plus 0 is half. Put zj minus cj. Get 2, 2 minus 2, that is 0, 1 minus 1 is 0, minus 1 and half. So this is my entering variable, but if I look at the ratio, what I'm getting is 20 by 0 and minus 10. So what does this mean? If I have this infinity here and a negative value here,
Unbounded solution.
yeah, we have an unbounded solution. I can keep increasing and still my basic variable won't come down to 0. Okay, so this was an example of unbounded solution, and the previous one was an example of infeasible solution. Okay, so this must be some previous solution. So we did unbounded, and the first one was infinite solution, right? So this may be infeasible, but we need to check. So x2 plus x3 equals to 3x1 plus 4x2 minus 2x4 plus x5 equal to 12. So now we have an artificial variable, so we'll use the two-phase method. So phase 1, if you do simplex, what we will have be here x1, x2, x3, x4, x5. So we have 0, 0, 0, 0 and minus 1 as the position for the artificial variable. And here I'll have my basic solution I can use as x3 and x5, right? So this is 2, 12, 2, 1, 1, 0, 0, 3, 4, 0, minus 2, 1. So xb is x3 and x5. xcb is x3 is 0, x5 is minus 1. So hj minus cj get minus 3 minus 4, 0, 2, minus 1. Okay, so this is my entering variable, and I can compute b by xj here. So that is 2 and 3. So this is my pivot. So continuing the phase 1 iteration, you will have x3 exits and x2 enters. x2, x5. It's already 1, so I continue 1, 0, 0 to make this 0 into R2, R2 minus 4 times R1, right? So 12 minus 8 is 4, 3 minus 8 is minus 5, 4 minus 4 is 0, 0 minus 4 is minus 4, so minus 2, 1, correct? Do zj minus cj here. So the coefficients here would have been 0 and minus 1. So I get 6 here, 0, 4, 2, minus 1 plus 1 is 0. So I get zj minus cj greater than equal to 0. And what else we can see? We have the artificial variable is in the BFS, right? So we need to check uh, z star, right? Z star was what? 0x1 plus 0x2 plus 0x3 plus 0x4 minus x5. If we substitute solution in this, it is x2 equal to 2 and x5 equal to 4, and what I get is minus 4. So what does that mean?
Infeasible solution.
Yeah, it's infeasible. Like the corner points of these are such that I guess x1, x2 are not positive or something. That could be the case because you are getting an infeasible solution. Okay, infeasible normal solution. Okay, we can check this in graphically also, I guess. Uh, if I put x1 equal to 0, I get, say, this is 2. And if I draw this equation, x1 equal to 0 means x2 is 3 and x1 is 4. Okay, something like this. And it's this way. Okay, so somewhere here you have the feasible region, but in this region my x1 is negative. So this is the basic solutions here, but it's not basic feasible. So and this problem is infeasible, so we don't have a solution. Let's look at the next problem. Mm. Okay, so x1 plus 4 x2 plus x3 equal to 8, x1 plus 2 x2 plus x4 equal to 4. Let's see, j3 9. We don't need the first phase in this. x1 x2 x3 x4 8 4 4 0 0 1. So this is 1 0 x3 x4 0 0. So if I compute this, I get minus 3 minus 9 0 0. is entering b by xj, that is 2 2. So there is a draw. So what do we do in this case? So what does this mean? Basically, if there is a draw,
Degeneracy will occur in the next step.
yeah. So to avoid degeneracy, we do something, right? We look at some value.
Yes, yes. Now there is a criteria to in selecting the parting variable, right?
Yeah.
Yes. Please elaborate that criteria. I know, but I have a little bit confusion regarding this.
Okay. So that's what was the name of the method? It was chance perturbation method, right?
Yes, yes, maybe.
So you have to look at. So basically, that perturbation method, what it does is degeneracy means you have some redundant kind of constraints, right? It may be like extra constraint passing through the same column,
Hmm,
right?
yep. Yes, yes, yes.
So in degeneracy, you're perturbing basically your b value. Like the chance method is basically its proof is via perturbation. It's like you're perturbing the b value. So you are looking at b by xj instead of b by xj. You look at something else. So what you will be looking at is you have this BFS, right? So you look at min of what value? Yeah. So yeah, I remember now. So it says you have to okay, I think your confusion may be in this, but like you have to reorder the
Yes, yes, we
cases.
have to reorder. Like x3, x4 will become x1, x2, right?
Yeah, yeah.
And x1, x2, what will be the order? Like in any order we can take, or
So basically, this reordering is like you don't need to really reorder, but it's like you need to have a fixed order, and that fixed order should be such that you start with the basic variables and then the non-basic.
basic variable will be like identity matrix.
Yeah,
First x3, then x4.
yeah.
We cannot switch x4 and x3, right?
If you're doing like that x4 x3, then you have to stick to that order.
Okay, okay. And if suppose I choose x3, x4,
Hmm.
then I we have options for x1, x2, and x2, x1 both, right?
What do you mean option?
Options like order options.
Ha ha ha.
X, x3, x4, x1, x2, x3, x4, x2, x1.
Ha ha ha.
Both we can choose, right?
Yeah.
Okay.
So instead of b by xj, now you look at uh,
And one more thing, suppose sometimes it happens that like in basic variable, here it is x3, x4, right?
uh-huh.
Sometimes it is x4, x3. The then the 0 1 column will be above and 1 0 column will be below, right?
You mean this will be inverted?
Yes, yes, yes,
This will be
yes, yes. So then also I can take right x3, x4, or x4, x3, because both are options are available, right?
yeah.
Okay. Well, in such scenarios, I have confused. I have confusion.
Uh,
What will be the order and what?
Like basically, what you have to do is you need to, like, if it comes as ulta,
Uh,
then you do whatever the first ordering that you had used, you follow that.
okay, suppose it is x4 x3,
Uh,
then take first x4, then take x3, right?
huh.
Or we have to follow the identity matrix rule order.
No, not the entity matrix order. Whatever order you had first used.
Okay, okay, fine.
So yeah, we were looking at this thing. No? So instead of b by xj, now I look at this 1 by xj, right? So I'll get 1 by 4 and 0 by 4. Sorry, 0 by 2. So minimum is 0 by 2. So I'll choose that as my departing variable, right? This is for x4. So
X4 will be departing, right?
yeah,
Hmm. And if it is also a tie, then we will move the next column, right?
yeah.
Okay.
So ordering, the order in which you go, that should be maintained.
Yes, yes.
So
Because if we will take the order x4 and x3, then
mhm,
here x3 will be departing first, right?
yeah,
So yes, means the order will matter.
yeah,
That's why that's what I want to ask. Like, if we change order, then the departing variable will differ.
yeah. So if next time this you cycle again to this one,
Okay.
you may come in a different way. So that your x4 may come first or something like that.
Okay. So if it comes later, then we have to maintain the order which we have taken earlier, right?
Mhm.
Okay.
So he said x4 will depart now and x2 will come here. So you have 9 and x3 is 0. Cj, sorry, b is, he said this will be the pivot. So divide by 2, 1 by 2, 1, 0, 1 by 2, and I can do 2, this minus 2 times this minus 2 times this. So this is 0, 1 minus this minus 1, 0, 1 minus 2. Sorry. So I have zj minus cj, and this will be 9 by 2 minus 3, which is 3 by 2, right? minus 9 is 0. This is 0. This is 9 by 2. So this is positive. So solution is x3 equal to 0, x2 equal to 2, and x1 and x4 are also 0. Okay, we can look at the graphical thing also once, just for clarity. So x1 chooses 2, sorry, x2 equal to 0 will give me x1 8, right? So is 8. 1, 2, 3, 4, 5, 6, 7, 8. And x1 equal to 0 will give x2 equal to 2. So this is something like this. So I guess you have this kind of constraint. So here there are three lines. I think this is your feasible region. So this one is a kind of a redundant constraint, right? Redundant constraint. This one. Okay. So let's look at next question. Consider the graphical solution space in figure 3.18. So this is that figure I've taken this from some book. Suppose that simplex iterations start at A and that optimal solution occurs at B. Further assume that the objective function is defined such that at A, x1 enters the solution first. So this is our first BFS, right? First BFS. Identify on the graph the corner points that define the simplex method path to the optimum point. What will be the simplex method path to the optimum point?
It will move corner to corner, but I don't know what will be the cycle, counterclockwise or clockwise.
Hmm. also not sure. Like if we are at here, how did we decide where to go? It was based on like which is the departing and which is the
Maybe we can, if we start from 0 to 0, and we can check the value of objective function at point B, and
mm,
at the point uh, x2, in the x2 line, which whatever, like a will be there or e will be there. So if the maximum value where occur, we will move in that direction. Maybe
the objective is not given, no?
graphical solution space. No, assume that the objective function is defined such as at a x1 enters the solution. Okay. Okay, then I don't know.
But why is our first BFS mattering? Uh, like how does the objective solution determine the first BFS? That is one doubt I have.
Hmm.
Anyway, but this is the optimum solution, right? So objective function is something, something must be something like this.
Yeah, first BFS is 0 0, right?
Yeah.
So x1 is 0, x2 is 0. It means, and it's a decision variables are two only, right?
Yeah, I mean, there are many constraints, so there may be some artificial variables, and
This means x1 equal to 0, x2 equal to 0 will be optimal solution. Otherwise,
why?
but if it is basic feasible solution, first BFS it is, then it will give identity matrix, right?
No, first BFS is here means there is like x1 equal to 0, x2 equal to 0. That means these are not in the basic set. These are non-basic.
Yes.
But there may be some other variables which are non-zero, x3 sub x4.
But then how can we draw the graph, like, if it is many variable problem?
So objective value should increase, right? When you uh, move. So here also it will increase. Is the increase here more, right? Here the increase is most. But if I draw in some other way, in what way can I draw? I can draw like this also, right?
In all the cases, the D will occur at the optimum place.
No, I was thinking to say whether after A will it go here or here.
Okay.
So it will either be this, or this, right? These are
Yes.
the two ways that is part to the optimum point.
What can you repeat?
No, either it will be, I think here the name is not given. It can be A, E, D, or A, B, C, D, right?
Yes. Yes. Yes.
The B question question is determine the maximum possible number of simplex iterations needed to reach the optimal solution, assuming no cycling. Maximum number of iterations. So from A,
A to
E,
B.
D, it is 3 iterations, right?
Yes.
And from A, B, C, D, how much?
4.
So here it can have multiple iterations, right?
Yes. It may go from A to B, then it can go B to E.
From B to E, it can't go, right?
It cannot go, yes.
So from from C on C itself, it can iterate a few times. So A to B is one iteration, B to C is one iteration. Okay,
While
when
from C to D, it can iterate multiple times.
so in C itself, it can stay a few times because if you see, there are how many? One, two, three, four constraints.
Okay, okay. So these lines representing constraints, right?
Ah, so there are four constraints. So you need at a time only two constraints to be active.
Hmm.
So it can be so that means those extra variables that are there, they can come and go from the basic set.
Yes.
So you'll have four choose two ways. Four say two ways. That is how much? So 4 into 3 by 2, right? Is 6.
Why we are choosing 4C2? Because there are 4 constraints at C.
Yeah, 4 constraints at C, and like in each BFS, you will have two variables in the basic set,
Okay.
right? So there are four ways, like you can have two variables in the basic set. I mean,
Hmm.
4 say two ways.
Yes, yes, yes. It means number of basic solutions at C.
Yeah,
Hmm.
and then C to D again, one iteration. So here it will have 6.
No, wait. A to B it is 1. So one iteration will be counted at A or A to B. Because
Ah,
B to
okay,
C.
okay. Maybe we can just count the number of corner, like number of points it will be at. So it will be here once, here 6 times, and finally here. One, one.
Okay. Because this is something new for me.
Okay. So we can I think I have one more question or two more questions here. Uh, this is what this is. I think we just have to do the phase one, phase two thing. We will do the next question. It is and something different. So this one has to do with sensitivity analysis. Some company manufactures two products on two machines. A unit of product one requires 2 hours on machine one and 1 hour on machine two. For product two, one unit requires 1 hour on machine one and 3 hours on machine two. The revenue per unit of products one and two are $30 and $20 Total daily processing time available for each machine is 8 hours. Okay, so the objective will be to maximize the revenue, right? So let's say product 1 has x1 units of 1, next 2 is units 2. And you have to maximize 30x1 plus 20x2. Uh, what are the constraints? Product 1 requires 2 hours on machine 1 and 1 hour on machine 2. So for each machine there is only 8 hours. Product 1 requires 2 hours on machine 1. So 2 into x1. And product 2 requires 1 hour on machine 1. So plus x2 should be less than equal to 8 hours. X1 requires 1 hour on machine 2 and x2 requires 3 hours on machine 2. 3x2 should be less than equal to 8. And x1 x2 greater than 0. Uh, okay, the solution is there actually. So the solution for this is x1 equal to 3.2, x2 equals 1.6, and z is 128. So the question is, suppose the unit revenues for product 1 and 2 are changed to 35 and 25 respectively, will the current optimum remain the same? So if you change,
Yeah, and the solution will be given first, or we have to find it.
it was given actually, I forgot to write it.
Okay, okay.
So 35, like to find the solution, you just have to solve this, right?
Yes, yes, yes. And I think the current optimum remains same because in the constraints we are not changing anything.
Uh, but that doesn't mean the,
Just because the cost is also a factor
yeah,
in the cases.
like even if your feasible region may be same, but depending on how your objective function is, what is the corner point where it will, like it could be objective function could, if an objective function like this, then this could be the,
Yes, yes,
but if it is something like this, then this could be.
yes, yes,
So in this case, so in the sensitivity and in this part, I think some things were discussed, right?
yes. And in the sensitivity analysis, what we are supposed to do, even if we are changing the cost or we are changing the constraints and we are analyzing the solution, behavior of the solution, right?
Yeah. So this is the same thing, right? The cost function has been modified.
Yes, yes, yes. So for analyzing, we will do all the calculations, or there will be some theorems we can directly use results.
Yeah, so I think some things were discussed. Like if the cost is in changed only in a certain range, then only the optimal solution will remain the same. If it is beyond that, or if a certain cost is changed, then
Okay.
so in this one, if you see x1 and x2 are these will be there in your BFS, I guess, right? These two will be there in BFS, and the other variables will be in non-basic, because you can only have two variables in the basic solution. So one of the thing that was discussed is if your modified objective ck is ck plus delta k delta ck, if you have made this change and ck is not in the basic, basically the k that you have changed is not of the basic variable, then the optimal solution will remain unchanged. Okay, but in this case, can we say this?
No, x1, x2 are in the basis, right?
Yeah.
So
So
we
we
are
can't.
changing the C1, C2, we are changing.
Yeah. So we
So,
can't say this, right?
yes, yes, yes.
So if ck is in the basic set, then we have to look at a certain ratio, which was max of minus zj minus cj upon kj greater than 0. Okay, this is this we have to check. So how will this be? How can we check this?
I don't know. We have to take the values. That this is something which is new for me.
Hmm. Zj minus cj is what we compute in the simplex, right? So
So we need that table, right? If
yeah.
if we need Zj minus Cj, we have to we will need simplex table for earlier solution objective function. Otherwise, how can we get the Zj minus Cj?
Hmm. So let's compute that.
And this Zj minus Cj will be will from the table of earlier objective function or the modified one?
This is from the earlier objective function.
Earlier, right?
Yeah.
Okay. So anyway, if we know, even if we know the solution, but we have to compute.
I think here it should be delta ck.
Yes, yes, yes. Delta ck was there.
So let me compute this. 2x1 plus x2. Then just write 3 2 0.
And in the denominator ykj, what is that?
That is the entry corresponding to the coefficients. Whatever we get here.
Which one?
The coefficients that we get here.
Okay, okay. Solve it then we can.
This part.
Okay, but which one we will take? Like much.
So for different j's we have to check. K is the basic part, right? K is in the basic set.
This k is the like c1, c2, c3,
K is
right?
the row. J
Yes.
is the column.
Okay, so we have to check for different k's, delta ck, and for different j's.
So if you fix K here, this is fixed.
Yes, 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 yes. Okay, solve it. Solve this example, then the doubt will be clear. Yes.
So you will have here 8, 8, x3, x4, and 2, 1, 1, 0, 1, 3, 0, 1, CV 0, 0, then J minus CJ. This is minus 3, minus 2, 0, 0. Okay, this is the entering variable. 8 by 2 is 4, 8 minus 8, so this is pivot, right? Uh, so x1 has entered, x3 left, x4 is here, 3, 0, 4, 1 by 2, 1 by 2, 0, 8 minus 4 is 4, 1 minus 1 is 0, 3 minus half is 9 by 2, right? Sorry, 5 by 2. And then 0 minus half is minus half, 1 minus 0 is 1. Here I have 3 by 2 minus 2. 3 by 2 minus 2 is minus 1 by 2, right? by 2 and 0. So this is there, and we can just change this one because we know x2 can come is there in the basic set. So I have x1, x2. So I'll divide this by 5, 4 by 5, 0. So I have to divide by 5 by 2. 4 divided by 5 by 2, I get 8 by 5. Is that the solution? Yeah. 8 by 5, 0, 1, minus 5, 2 by 5. To make this 0, I can do divide this by 2 and subtract from there, right? 4 minus 4 by 5 is 16 by 5. 1 minus 0 by 5. 0, half minus 1 by 10 is by 10. 0 minus 1 by 5 is minus 1 by 5. Okay. So here the coefficients were 3 and 2. 3 minus 3 is 0. 2 minus 2 is 0. 0 minus 3, 3 is 9 by 5 minus 10. Yeah, this will come negative, no? That shouldn't happen.
Fifteen upon five and 8/5 must be there.
Where?
No, no. For the solution,
Yeah,
where is
16,
it 3?
16 by 5, 8 by 5 is there. I think here somewhere I made a mistake.
Yes, yes.
What did I do here?
I was not following the calculations.
So I had to do this and divide by 2 by 5. So I got 8 by 5, 0, 1. If I divide this by 2 by 5, I should get minus 1 by 5. No? Yeah, that's the mistake. So this is 9 by 5 minus 2 by 5, 7 by 5.
Minus
So
3 plus 2 for 1 by 5, yes.
so so I need to check basically minus 7 by 5. So max, right? So k is these two. That is what. So if I fix k, that is this. So I have 0 by 1, right? Comma 7 by 5 upon 3 by 5, which is equal to 7 by 3. Initially minus 0. So here I have taken k equal to 1.
If k equal to 1, then how we
This
are
is
going to
5.
zj minus ej, it means z1 minus c1 and z2 minus c2, right? 0 by 1, how we get?
0 by 1 is this 0 divided by 1. K
Okay,
equal
that,
to 1 means I am considering this row.
yes,
So I do minus like 0 by 1.
yes,
Because this is 0, I don't consider it. 7 by 5 by 3 by 5.
okay.
Because this is negative, we don't consider it.
But it will become positive, right? Oh, okay, okay. For YKJ has to be positive.
Yeah.
Okay.
So for this, I consider YKJ that is negative, that is only this one.
Hmm.
So it is minus 1 by 5 divided by minus 1 by 5, which is 1. Isn't it?
Yes, it means delta C1 lies between 0 to 1.
That is not correct, no? Oh no, that is correct actually.
Yes, because the condition is if CK and the delta
I
CK.
I have to take 0 0.5 actually here.
Yes, yes, yes.
Yeah, yeah. Because I considered 3 to and it instead of 30 20.
Delta C1 is what? How much? Like 5?
Delta CK actually, okay, I did something different.
No,
instead of
because
instead of
actual.
putting 30 and 20 here, I put 3 2. So this
Uh,
is like 3.5 x1 plus 2.5 x2. So
okay,
delta C1 is zero point 0.5.
okay, that is 3.5 or $35.
It was $35, $25. But
Okay,
when I was doing the simplex,
yes,
instead of putting 30 and 20, I put 3, 2. I don't change
Okay.
the answer.
Okay. Yeah, fine.
And here, you can scale it now, basically.
Yeah, 3.5, 2.5.
Yeah.
Yeah, it will be 0.5.
Yeah. So delta C1 equal to 0.5. That satisfies this. What does
Yes.
that mean?
The
That,
C1 will improve by delta C1 into X1.
yeah, like that means the solution will be same. That is
Hmm.
x1 equal to 16 by 5, x2 equal to 8 by 5.
Hmm.
And if we had changed only C1, then it would have increased by zero point 0.5 into what was the value? 16 by 5.
And X1 will be like this solution. 16.5, 3.5, right?
Yeah, x1, x2 will be the same.
Yeah.
But here both have changed. So it's the second one also we need to check. If both of
Yeah.
them satisfy, then we can say more.
Okay. If one satisfies, one not satisfying, they.
Then we can't make this conclusion. The optimal solution may change.
Okay.
So let's look
Hmm.
at the other one also. So I have to look at this row. So I have 0 by 1 and hmm,
Minus
1
1
by
by 5 upon 2 by 5.
2 na basically.
Uh, minus.
Oh, sorry, minus. So this is 0.
Hmm.
Delta C2. So basically, again 0.5 only. Right? And this one will be, it's negative only here.
Yes.
Minus 7 by minus 1.
7. That is.
This is also satisfied. So we can say the objective value will be increased by zero point 0.5 into 16 by 5 plus zero point 0.5 into 8 by 5. Delta L.
Okay. The objective function will improve by this value and the optimal value will become like z plus this delta z, right?
Optimal, like x1 star, x2 star will be same.
Yes.
Only the objective value will improve.
Yes.
So current optimal, like the solution will be same, but the value will change. Optimal objective value.
Yes.
Okay. I think we'll.
Yes, we should stop it.
Any doubts here?
No, right now. But yeah, sensitivity analysis, there will be a lot of doubts from my side
Okay.
in the next tutorial.
Yeah, I think the next lectures it is discussed in
Yes.
more detail.
And that one query was not resolved. I have mailed in discussion group
Uh-huh.
और असाइनमेंट टू में मतलब जो क्वेश्चंस में दिक्कत था
Mm-hmm.
वो दो क्वेश्चन सेम थे बट उनके आंसर डिफरेंट डिफरेंट हैं.
Ah, you said.
यस उन्होंने अभी इवेल्युएट होके आ गया है तो उसमें आंसर मैंने मार्क किया था वो गलत कर दिया मतलब दूसरे वाले क्वेश्चन में.
Okay. Did you check the solution?
हाँ नहीं दो क्वेश्चन सेम है
Oh, the options are different. Different.
उनके ऑप्शंस भी सेम है
Huh.
दोनों में सेम मार्क किया मैंने
Huh.
आंसर भी सेम ही होगा ना. बट सपोज एक पहले क्वेश्चन में बी ऑप्शन सही है सेकंड क्वेश्चन उसमें भी बी होना चाहिए बट उसमें उन्होंने अलग कर रखा है.
Okay. Okay. So you're saying in one question you got full marks in the second question. You didn't get full marks.
यस यस यस।
Okay, okay.
एंड अरे क्वेश्चन में जो मेरा आंसर नहीं मैच हो रहा था उसमें, मतलब मैंने ऐसे रैंडम तो गेस करके मार दिया था,
Yeah.
उसका सोल्यूशन मतलब वो आ ही नहीं रहा है, वो भी मेरा गलत हो गया।
Okay, I'll check. I'll check it.
ओके, इन असाइनमेंट टू। यस,
Yeah.
प्लीज।
Okay, then I'll stop the recording.
ओके।